Apple called the new Siri your most personal assistant ever. Personal is doing serious work in that launch. It's the word you reach for when the real story is 5 models and a router. Count them. 5. 2 run on the phone, 3 run in a data center. And a piece of software decides, request by request, which one runs. So here's what I want you to see. The demo was a better Siri. The architecture was something else. The obvious read? Apple bolted Google's Gemini onto Siri and called it done. That's not what shipped. It's the opposite. Apple co-developed the models with Google, then built something Google ships to no one. A frontier-scale network that turns on only a slice of itself. Strip the marketing and the claim reduces to one thing: placement. The hard problem in phone AI was never how smart the model is. It's placement, where the computation happens, and what it costs when it happens in the wrong place. Think of it like a hospital. You don't send every patient to the specialist wing. A triage nurse reads the case at the door, keeps simple ones local, sends complex ones deep. Apple built that nurse in software and called it a system orchestrator. But that's not the part that matters most. The advanced on-device model uses a sparse design. Instead of lighting up every internal dial, every parameter per request, it switches on only a slice of a much larger network per query. Apple's AI chief said the quiet part on the record. You're not having to reload parameters with every token, and this dramatically cuts down the cost of loading these parameters. That sentence is the architecture. On a phone, the enemy isn't compute, it's memory and battery. Every dial you swap in to serve a single word of output costs milliseconds and heat. On-device privacy is doing serious work in that release. But the deeper reason it's sparse isn't privacy, it's thermodynamics. You can't run a dense frontier model against a battery without the phone going hot and slow. Sparse activation cheats that without shrinking the model to uselessness. I call this the placement tax. Every AI feature has a hidden bill, set not by model size, but by where weights live and move when used. Apple made that tax the center of the design. 2 on-device models, 3 server models, an orchestrator between them, all to pay the placement tax in the cheapest currency, per request. To be fair, sparse activation isn't new. The frontier labs have used it for a while, and Apple is late to a real assistant. The question is whether being late let them design the routing layer on purpose instead of bolting it on. And that's the seam. Apple didn't optimize a model. They built the layer underneath it, the part that decides which model runs. The intelligence isn't in the weights, it's in the dispatch. If you're the staff engineer who reads the architecture diagram before the launch blog, you already see it. Weights are becoming a commodity you can co-develop or license. The orchestration, the runtime, the silicon under it, that's the part nobody copies in a weekend. Apple opened this to you too. That same on-device model now ships in the foundation models framework, reachable through one swift programming interface. That locks something in. Build on it and your inference runs where Apple decides, under their orchestrator. No flexibility on routing. It compounds into a dependency that deepens every OS release. The better the runtime gets, the more expensive leaving becomes. Within 12 months, every serious consumer AI team makes this call out loud, the one Apple made quietly. Not which model is smartest, but where does each request run, and who owns the layer that decides. The model wars get the headlines, the placement layer wins the platform. Who else is building one of these routing layers is its own episode. We'll come back to it. Watch where the computation lives. That's the decision Apple already made for you.